Hey everybody, and welcome to Spindle TV. My name is Laney Shaughnessy, and I hope you're all doing well this evening. I am doing very well. Got a pretty cool project. It's not my project by any means. I'm not the first one to do this project in a video and all, but sliding lid boxes are really cool to make for all kinds of different occasions, for different holidays or gifts or whatever. Nice little keepsake boxes for selling, whatever you want to do. And I happened to come across a video on YouTube. A gentleman by the name of John Clark made a video of making these very nice two-tone sliding lid boxes. And he was making them on his Shapoko CNC, and he created the design, or his video kind of demonstrated creating the design in Carbide Create. So, and they were very nice boxes and everything. So you could definitely check that out. Sliding lid boxes by John Clark. What I wanted to do is I wanted to put my spin on those same type of boxes, but in Vectric, creating the designs and the toolpaths in Vectric, laying out those types of things. But I want to add a couple of elements to it. I wanted to add maybe some nice V-carve inlay work to the lids, or maybe some nice laser work if you guys and girls have digital lasers. And things like that. So that's what we're going to be doing tonight. I don't know if he'll pop in tonight, but we had a commenter on last week's video talk about closed captioning or subtitles for different languages and everything. I believe I did it right. I set this one up for a couple of different languages. I know Russian was one of them. I think I have a gentleman that always asks me to translate my videos into Russian. But I am still researching on how to nail that down to where it translates everything I say clearly without me having to actually type out the translation and stuff and submit that file and everything, which is how I used to do. I used to dictate all of the videos, submit that file, and then it would create subtitles in the appropriate place and everything for it. I know YouTube creates like a closed captioning. It kind of has like a default feature and stuff. But as far as translation into other languages, give me some time. I'm working on that, but I will make that happen for those folks that English may not be their first language and everything. So, that being said, welcome everyone. I appreciate you all. Hey, Chris Leach, Chris Woods, David, Jonathan. Hey, Jonathan, how you doing, buddy? David Bemis, Rodney, Jeff, Robert, Roger, and Ronnie Probert, Mike Smith, Kool-Aid, James Farrow. How y'all doing? These are just the names that are kind of popping up on the screen here. I appreciate all of you stopping by and spending some time with me tonight. We're going to be working in VCarve Pro, so that being said, let's go ahead and jump over. I believe that is camera 3. So let's go ahead and do that right now. Camera 3, there we go. And let's get me down in the bottom left corner. All right. Looks good, looks good. I keep looking over my shoulder because that's where my monitor is. One of these days, I will mount that monitor in front of me, so I'm looking forward when I'm trying to set things up and all that good stuff. But yeah, so we are, this is a great project, by the way, guys and girls, for scrap woods. If you have little blocks of scrap and you don't just know what to do with it, this is an awesome fallback project, these little boxes. They can be made out of 3/4 inch material, but it would be better as far as holding capacity, more holding capacity, if they were around the 1 1/4, maybe 1.5 inch deep boxes. But absolutely, you can make them in different diameters. You know, 3/4, 1 inch, 1 1/4, 1.5. anything less than 3/4, it's not really feasible for a box and all. But for tonight's project in our setup here, I am going to work with a small scrap piece of wood. We're going to have a piece of wood for the base of the box, and then we're going to have a piece for the lid. And these boxes really look good if we can use some contrasting materials, maybe a walnut base and a maple lid, or walnut base and cherry lid, or just some nice contrast to it, right? And then if we do anything like inlay work or laser engraving on the lids or anything like that, it'll really stand out. So we're going to work on the base first, and I'm going to be drawing the lid in here as well, but we're going to transfer the lid over to another design file, basically, with the appropriate thickness on that. When it comes to the lids, I'm partial to 3/8. We can go 1/2 inch or less, but 3/8 is a really nice lid. If I'm working with 3/4 inch thick material, then maybe we can bring that lid size down a little bit narrower and skinnier. But for this project, we're gonna go with a 6" by 4" block. It's going to be 1¼ inch thick. Could be 1.5 inches, if you've got that laying around, but 1¼ inch. And sometimes you may have some rough sawn lumber scraps laying around, end cuts or whatever the case may be, that would be great for these types of boxes. And they might not be milled or planed, and we could surface plane them on the CNC if we needed to kind of flatten them out and all. But I'm going to go with 1¼ inch. So we've got a job set up here. It's going to be a single-sided job. It's going to be 6 inches along the x-axis for me, 4 inches along the y, and 1¼ inch in thickness. For this, because the box is going to get cut out of this, I can have room for clamps if I wanted to. It's not going to take up the full size of this block, so I could put some clamps on it. I could definitely use two-sided tape and CA glue for holding it down, hot glue, things like that. For the touch-off, I'm just going to register off the material surface because there is going to be some waste area to of my surface that's not going to get milled that I can work with. If that becomes a factor, then we can always work off the machine bed, our waste board, if we're going to lose any of that surface for milling or anything like that. But for this project, a very simple setup. We're going to work off the material surface, and I'm going to reference off the bottom left corner of the material. But again, this is something you could probably register off the center if you wanted to, and all that stuff for your XY datum, our start position, our home position for our X and Y. But I'm going to work off the corner. We're going to go ahead and click OK, and we're going to come in here and we're going to start out with our base layout, the box layout and everything. Now these box layouts, I wish I used to have a very nice box, but as an example for this, but I gave it to my sister as a gift. She came and visited one day and really liked it, and I gave it to her. And it was a really nice one. But these boxes are going to have a channel in the lid, so the lid can slide off, and the lid's going to be able to close with magnets. So it's going to snap shut with magnets, and the magnets are going to hold real strong. Now, John Clark, in his video, he had a link to an eBay site that he referenced for the magnets. However, they're out of stock. But these magnets are 1/4 inch by 1/4 inch by 1/8 inch square neodymium rare earth magnets, around a rating of N48, and they came in a 50 pack for $11.99, which was a great price. But they're out of stock. Now these magnets are sold by a company called Total Elements, and if I were to look up Total Elements website, They're running around $13.99 on the website, but they're also out of stock. And it's like, okay, well, these would be the perfect magnets. So where could I find some that are in stock? Well, through looking around and everything, I found them at Amazing Magnets online. And with Amazing Magnets, let's go back in here. They are they're a little bit more expensive. They're going to run around 39 cents a piece. They come in blocks of 50, just like the other two on eBay and Total Elements and everything. And so that's going to bring me around $19.50, not counting any tax or shipping, what's in there. But let's back up here again. And so Amazing Magnets had them. What we want is we want a magnet that's magnetization, or it's let's see the best way. Yeah, magnetization is along the thickness and everything, and it has a basically a north and a south pole, on its flat faces and all, but we're going to be inserting them into these boxes on edge. So we want to make sure that when we put them in and install them in, that we want to make sure the polarity is right. And in John Clark's video, he's got a nice little technique where he will put the two magnets together that are going to go into the lid and into the base. And he'll go ahead and press them in. That way he makes sure, he'll have the lid with the box and he'll press them in, and then he'll go and seat those magnets, but it'll make sure the polarity is correct on them and everything. But Total Elements was out, and so I was able to find the same magnets. Now these, instead of an N48, they're an N52, so they're a little bit stronger. We don't want them too strong. The N48 is about 3.25 pounds of I don't know how they rate it. How do they rate that? Pull force. So pull force. And these are N52, so they have a pull force of about 5.1 pounds. But they also, on Amazing Magnets, they also have an N52 that has a 2.8 pull force on there that might be probably more suitable for the box, but they're the same price. So about $19.50 for a block of 50. That's not bad at all, in my opinion, for these small magnets. And they're great for these little gift box type things. And we could be really creative with our box shapes. They don't have to be square and rectangular, which is what we're doing tonight. They could be round. They could be, all kinds of things. And we're gonna look at a couple of those designs. All right, so. Total Elements is out of stock. The eBay link is out of stock. So Amazing Magnets, and what I'll do is I'm going to put the link. I'll put the link in the description of the video, but I'll also throw the link down in the chat area. I'll throw the link down in the chat area for the ones at Amazing Magnets, and I'll also throw the link for the ones that are at Total Elements. And but they're, just know that the ones at Total Elements are out of stock, and they could be back in stock soon. I don't know, right? Without checking with them, but I'll throw that link. I'll throw that link in there as well for you, for Total Elements. And yeah, HD Home Depot carries rare earth magnets and all. And what we want, mostly what we want, is we want the 1/4 inch by 1/4 inch by 1/8 inch thickness, and we want the magnetization along the thickness and everything. So that's kind of the key things with these, right? So 1/4 inch by 1/4 inch by 1/8 inch. Okay. All righty. And hey, Cadley, thank you for coming from St. Lucia in the Caribbean. Thank you for that. I appreciate you stopping by. All right. Sorry, I had to wet my whistle. Okay. So, like I said, great scrap wood project. What we're going to start off with, on this box, I do want radius corners. So let's go ahead and start off with our rectangle. And we're going to go on our overall length here. We are going to go, you know, the 6 inches. That is a decent size box. It's a pretty good size. I mean, it's a pretty decent size box. Of course, now these can be scaled to various sizes, right? Smaller, bigger, whatever you want. It could be a ring box, whatever the case may be. But we're going to go with 6 inches. And on my 4-inch width, I'm going to go about 3 inches. Let's see here. Bear with me. 3¼ inches wide. So let's go 3.25. And I would like a radius on the corners. I'm thinking that just a nice subtle radius so it's not sharp corners and everything. Probably a 3/8 of an inch radius on there. And yeah, that looks good. All right, let's go ahead and get that centered on our board. And we'll go from there. All right. Now, within this box, we're going to have the pocket area that's going to be, you know, pocketed down for the, you know, the holding and all. And the thickness of your walls, that's going to vary based on your needs and stuff. I'm going to go with a 3/8 inch wall. And I think the maximum I would go would be a 1/2 inch. But I'm going to go with a 3/8 inch wall. So we're going to offset this inward. That rectangle inward. We're going to go 0.375. Let's undo that. I don't want sharp corners on that. Let's bring that in. It's going to give me sharp corners, but I'm most likely going to go ahead and round those as well based on the diameter of my router bit. So let's go ahead and do that now. I'm going to go to the fillet tool. And on that fillet tool, let's go with, I'm going to use a 1/4 inch end mill. So we'll go with an 1/8 inch radius. And let's kind of radii that inside area and everything here. All right, cool. You guys with me so far? Now, on the ends, I actually want to bring them in a little bit because our magnets are going to go on the ends. And our magnets are going to go, they're going to be inserted in, so we're only making about an 1/8 inch, you know, kind of opening for them, and they're going to be pressure fit in. These with the pockets and everything, and John Clark, he kind of did all the homework for us on the magnets and stuff, but they are a nice friction fit. When they get pressed into place and you make sure they're flush with the surface, they're not coming out. I'll get you this. We'll get the size of that in a minute. But I would like on the ends, I would like it a little bit wider than that 3/8 of an inch. So what I'm going to do is I'm actually going to undo my 4 corners, and I'm going to get this sized down. Let's do this properly. Let's go to the size tool, and on the width, I'll give myself an extra 1/8 of an inch on each end, so I'm going to go with an opening of 5 inches because it's at 5 1/4 right now. And let's do that again. Uncheck. I don't want to. I want to unlink the X and Y. I don't want the X, the Y to change. I want to keep the 2.5. But let's go 5 inches there. And bring that in, and then I'm going to go back to my fillet tool and put that 1/4 inch radius in. The reason why I took them out is sometimes when we're sizing, when we have radius and all, the radius is going to get affected by how we scale this design and everything, and I didn't want them to be any kind of funky shape or anything like that. Cool. Hey, Stan Phillips, Mike, what's happening, guys? All right. So now that we have kind of a literally very simple base kind of with our pocket opening here, let's go ahead and create our rectangles. Now on the where the magnets are going to go, we're going to go with a size of on the length, which would be the height here. We're going to go with 0.305 and a 0.13 on the width. And this little opening, when we cut it with our 1/8 inch end mill, our end mill will be able to go in there and do a slight little pocket and everything. We're going to go down about 0.26 inches deep and everything. Give us a little bit of playroom and stuff. But the numbers, John did some homework and everything and testing and all that. And when it gets milled out, it's going to be a very nice fit for a 1/4 inch by 1/4 inch by 1/8 inch square magnet. So thank you, John, for doing that for me. So we're going to go 0.305 on the length here with a 0.13 on the width. So the height and the width. And I want to make sure that, I'm centered. And so let's go ahead and select that. And I'm going to align it to my material up and down here. And as far as being centered, in this area here, I can go ahead and just simply, to help me out, I can draw a rectangle. Whatever, size that I, wish it to be and everything. And I can use that rectangle to my advantage to align me left and right. So if I select my rectangle here first, hold down my shift key and select this rectangle last, which is kind of, the width of the edge of my board and the edge of my box, should I say, and the inside pocket, I can now use my alignment tool and align to that last selection, which is that larger rectangle. And I can go left to right and I can center it. That way I'm perfectly centered right there in that area. And that's all I'm using this box for. So use shapes to help you align, use guidelines, use whatever, means necessary. Use measurement tools and things to help you quickly and easily get to where you want to be. And now that I'm aligned exactly where I want to be here, I want to mirror that exactly to the other side. So let's go ahead and mirror that in our mirror tool. I want to create a mirror copy, flip it about job center. So I want those two options checked, and I want to flip it horizontally, and boom. Okay. So we're going to be, pretty good here. Now let's take a look at a side view of these boxes so we can figure out how our lids and everything work, because there's some additional work that needs to be done here. There's some additional vectors and stuff. But let's look at a side view. Let's say that this is a side view of the box. And my lid is going to, let's say that this is my lid here. So we'll kind of zoom in and focus in on that. My lid is going to slide within a channel. Let's bear with me while I draw this out. Let's get the lid sized right. Zoom in and snap. Oh, come on now. Snap over to here. There we go. My lid. I just went blank, guys. Bear with me a second. Let me draw this properly. Oh, I'm an idiot. Hold on a second. That rectangle was throwing me off. I need a rectangle over here. Nice. And a rectangle on the other side, the same size. I'm going to use a line to help me out with that. Let's draw a line there. Oh my goodness. All right, let me take this rectangle here and flip it about this line. So if I select that rectangle and that line, I can use the mirror tool and click flip about line. There we go. And now I can size this appropriately. Let's delete that rectangle. We don't need it. And let's delete or trim, should I say. Let's trim. Oh, don't you do that to me now. Bear with me. Do the same thing over here. I'm going to pull these down because I need to trim this and this. Let's move the lid there. Great. Oh, I don't know why I just moved the lid. Let me finish trimming. There we go. Same thing here. All right. And now let me redraw this rectangle. Oh, I'm just screwing the pooch in all kinds of ways here. All right, guys. I'll get my mind on straight here in just a second. Let me move this up. All right, so we're going to trim. Oops, come on now. Are you going to mess with me today? Oh, why are you messing with me, trim box? My Vectric is playing all kinds of games. Why are you doing that? Alright, hold on a minute. It wants to play mean, so I'm going to pull this box out and this box out. I don't know why I'm struggling on this. Alright, here we go. 1, 2, there we go. 1, 2, perfect. Let's get rid of this line here. Holy bejeez Louise. Alright, on my box base, let's go ahead and let's bring this lid down. Right here. Okay, let's get it down where it touches and nice and pretty. And let's go ahead and select this lower rectangle, select this lid, and trim, clearing the inside of that last boundary, which is the lid. And there we go. So this is what my box is going to look like from a side view. Holy camole, it took forever to get there. But that lid is going to slide within this center channel on our box. And so it will slide in, or it could just close right down on, but you could slide it open. You could pop it up either way you want, but it's going to fit within this channel. So my base has to have not only its main pocket cut out, but it also has to have a shallow pocket for where the lid is going to recess. And I'm sorry it took so long to get to that conclusion, but my trim tool just wasn't working for me. And you're like, no, Laney, your trim tool was working. You were just doing it wrong. All right, so basically kind of this is a side view, if you will, of our box lid and everything. So what we need is we need a pocket vector that is going to remove kind of the top surface here before it starts pocketing in here. We need that vector, and we need to, you know how much of a lip we need for our lids and things, right? So I'm going to take and draw a rectangle. Let's get a rectangle drawn, and I'll get it in place in a minute, but let me get it drawn first. And what I'd like is just a small portion of from where my opening is that gets pocketed out to where the little lip is that comes up. I want to kind of split that in the middle. So if I were to take a line to help me, I'm going to draw a line from the outside of my box to the inside pocket. And what that will allow me to do is it will allow me to grab the center of my rectangle and snap it right to the center of that line here. And then all I have to do is go into my alignment tool and align left to right on my material. Okay, so you will see that in just a moment. And let's go ahead and hit delete on that line. And so basically this outside area right here is going to be raised up on my box. We're going to have a small channel coming down, and then we're going to have the flat bottom. Now I'm going to mirror this box here. I'm going to flip it vertically to the other side. And this is kind of my protected area here. And what that's going to allow me to do now, it's going to allow me to draw a rectangle and kind of snap that rectangle to those two boxes to the outside edge. And that is going to give me my pocket vectors, so we can get rid of them now. And so that center area is going to be pocketed out down a certain depth, depending on what we want. We'll figure out the heights and everything in just a moment. Then we have our very inner pocket. Then we have our magnet holes, and then we have our profile cut. So the base, as far as layout, is done. Let's go ahead and figure out how deep our first pocket needs to be, and then we'll go from there. So on my lid, like I said, I'm going to use, I like a 3/8 inch lid, because a 3/8 inch lid, it gives me some meat for a shallow inlay if I'm going to do inlay. It gives me some meat for plenty of meat if I'm going to do a laser engraving. Even if I wanted to do some V carving in there, I have 3/8 of an inch of material to work with, and on such a small box, my V carve wouldn't even carve that deep, right? So once we get our heights figured out, then we'll be ready to kind of do some design work on the top of the lid when we get it drawn. So let's imagine that this is my lid here. I would like the lid to be an overall height of 3/8 of an inch. I would like at least at a minimum 1/8 of an inch thickness to 3/16 of an inch. So maybe half and half, right? And for me, a little bit more, because I want to be able to round over the edges, kind of when I break the edges with the sandpaper and everything. I want a nice edge and stuff on the top of that lid. So I'm going to go 3/16 of an inch and 3/16 of an inch for a total of 3/8. So I'm going to kind of split that lid. So what I need is my pocket cut here to be 3/16 of an inch deep. Okay, 3/16 of an inch deep. So let's go ahead and let's start creating some tool paths on the base, and then we'll come back and draw the lid. So I made sure that my rectangle overlapped my board, so I get a nice clean channel cut so the lid can slide through very easily. And we're going to do a pocket cut. We're going to go 0.1875, 3/16 of an inch deep with a 1/4 inch end mill. This could be, for all better term, it could be an offset cut. It doesn't have to be a raster with the grain or anything like that. It can be an offset tool path that'll be a little bit more optimized, a little bit faster. So we'll do an offset tool path, and we'll go ahead and calculate this. If you want to add ramps to your tool path, absolutely do that. But what we want is, let me, for speed's sake, let me turn down my preview quality. Let's tilt this a little bit here, and let's preview that toolpath. So basically we're going to be opening up, And I gave myself a little bit of an overhang, but not enough overhang. Let's look at this preview and let's look very closely here, and we can see that we still have the radius of the bit showing on the ends here, on the end cuts and everything where it comes in. I don't want to have to do any chisel work or clean up on that. So let's go ahead and make our box just a little bit larger. And I'm just gonna, all I'm gonna do is hold the shift key, grab the side, and just pull it out, and it'll do both sides at the same time. Just gonna pull that out a little bit more and simply recalculate that tool path. Now, looking at this with there, so now we've got a nice channel area running down the length of our box. And our lid's going to slide right on that. And also you can close just from top to bottom, you know, close down in, and magnets are going to hold it very well. It'll be a nice little tight, secure keepsake box. All right, so inside our inside pocket, now this is 1 1/4 inch thick material. I've already removed 3/16 of an inch, so my inside pocket cut is going to start at 0.1875, and I would like to on this go down at least probably maybe 1 inch deep. I want to give myself some capacity for this small box, some capacity for holding whatever it may be. You know, it could be, you know, holding my, you know, private stock of jelly beans. It could be whatever, you know. I'm going to, from that 3/16 where I'm starting, I want to cut down another 1 inch. Okay. Actually, 0.875. I forgot this is not 1.5 inches. It's 1 1/4 inches. So I'm going to go 0.875, and that'll give me good capacity there. So again, we're going to go ahead and calculate that tool path. Preview that visible tool path, and that's going to be our pocket cut. Thanks, Blue Knight, for telling people to hit the thumbs up if you like these kind of videos and stuff. And I'm looking so forward to where, not only on these small projects but bigger projects here coming very soon, we're working on it, where we can do the full-length build videos as well as these cut out software training videos where we're actually go out and make these from start to finish. And I say start to finish, I'm talking about start to finish, you know. So you know, preparing our material to the milling, to doing the finish work, all that good stuff. I'm looking forward to that very much so. I'm looking forward to that. All right. So as we wrap up here and everything, we'll turn this box on its side, and so this is going to be basically my little keepsake box here. Let's go ahead and create our toolpath for our magnet slots, and we're going to use this base to lay out the vectors for the lid in just a moment. I'm going to show you how I'm going to do that. But this is going to be a pocket tool path again, but this time we're going to be using an 1/8 inch end mill. An 1/8 inch end mill. And we're only going to cut down, the depth is going to be 0.26. 0.26. Our magnets are going to be a 1/4 inch by a 1/4 inch, so 0.25. It's going to give us just 0.010 of an inch of you know, playroom, because again, there's not going to be any glue, any epoxy, anything like that. It's going to be just a nice pressure fit in. Again, this will be a nice little offset cut, and we'll calculate those tool paths, and we'll preview that. And these will be our slotted holes there. And the radius corners, that's why we went with a 0.305. That magnet will fit in, and we'll barely see those little rounded edges. It'll be a nice fit on that and everything. So this is going to be our base layout. Very simple box. Again, this particular design can be scaled up or down with the sliding lid, magnetic lid. It could be scaled up or down to whatever fits your needs, right? But we have basically our 4 vectors. We have our perimeter vector, which we haven't done that toolpath yet. We've got our inside pocket vector that's going to be where everything gets held or kept. We have our vector for the lid slot that's going to be created, and then our 2 magnet holes. And again, those magnet holes are 0.305 in length by 0.13 inches wide and a 0.26 inches deep. Okay, so now with these vectors here, what I'm going to do is they're on layer 1. I'm going to come up to my layers and I'm going to create a new layer. Okay. And on this new layer, I'm going to go ahead and change my color. Let's go red on this new layer. And on layer 1, I'm going to pretty much lock that layer. And what that does is that protects that layer from, I can't move anything while I'm drawing the vectors out on the other. So I can't select it, none of that stuff. It's locked and protected. Okay. Now, before I lock and protect that, I'm actually going to unlock that real quick. Let's unlock that. And I'm going to take this outside perimeter here and my magnet holes, and I'm going to copy those to that layer 2, and then I'm going to come back and lock layer 1. Lock that. Okay. So we can see our basically the red lines here, and that's going to be our lid, and it's going to be our magnet holes. Now the lid is going to get cut. Basically, when we do all the work, we're cutting from the bottom side. We're cutting the magnet slots in it because it gets magnets as well. We're cutting the magnet slots in there, and we're cutting the 2 channels on the 2 sides of it. So make sure when you are cutting the lid piece, the thinner piece, 3/8 inch piece, that you choose the nicer side that's going to be the top, right? Because we're going to be carving on the bottom of the lid. So make sure you don't accidentally, you got a really nice looking cool green pattern or something weird or whatever, and all of a sudden you mill it and go, oh, that's the inside when I needed it to be the top kind of thing. So make sure you kind of mark that or what have you. So we're cutting from the bottom side of the lid, if you will. With this lid and everything, now what we need is basically our vector that we use to channel out. That vector is what is going of our lid. That's what's going to remain, and we're going to be channeling out these small edges here, these 2 edges. With these edges, I want a nice fit and everything. So all I need for this is make sure I'm in layer 2. Make sure I'm in layer 2 here. And I'm going to create a rectangle. And I'm actually going to snap to that inner rectangle. And just make sure that I'm past that lid there. And let's grab this one and snap it to there. And that's going to be the vectors I need for the lid. Now that I have those vectors, I'm going to take them over to another program because it's going to be a thinner piece of material. I don't have to. I could create the tool pass here because everything is getting zeroed from X and Y from the bottom left corner. It's just going to be a thinner piece of material. I'm going to be zeroing out on the top of the material. I don't have to create a whole separate program. I could just make sure I name my tool pass, lid, 3/8 inch material, something, so I know what they are. But for visual purposes for you guys and girls, I'm going to put it on another so we can do the preview and stuff. So I'm going to right click and open up a new VCarve Pro window. I'm going to open up a 6 by 4 by 3/8 inch thick lid. Again, nothing changes. Material surface, I'm going to work off the bottom left corner, so we'll click OK on that. And then all I'm going to do is I'm going to select all of my lid vectors, copy them, and come over and paste them in this design, right? So I've got them here. Okay. Now, before I move over to do the final toolpathing on the lid, let me create the very final toolpath for this box. I can go ahead and shut layer 2 off now and come back and unlock layer 1. And I'm going to do my profile cut. So this is going to cut the full 1.25 inch deep with my 1/4 inch end mill. I can go ahead and go 1/8 of an inch per pass on this. I want to be on the outside of the cut. It probably would be helpful to put some tabs in there, right? So we'll throw some tabs in. My tabs are only going to be about 1/4 inch thick, and about 1/4 inch in length and about 1/8 inch thick. They don't need to be very thick for the tabs. And so we'll go ahead and throw a tab here and here, and one down here and here. Okay. Let's bear with me a second. All right, so let's go ahead and calculate that toolpath. If you want to add a ramp, you know, a nice ramp or whatever you can. I'll probably do a zigzag ramp, and let's go a 1/2 inch ramp, and we'll calculate that. Okay, and so on the cutout you can see how much room I have left, you know, and everything. So when you're clamping, maybe the two-sided tape method, or the painter's tape and CA glue, or hot glue. If you're going to use mechanical clamps, make sure if you give yourself a little bit of room, right, or make sure your clamps aren't overhanging, because we do not want to run into this, because the ends are going to get cut out and all that happy jazz. But this will be my box. All I'll have to do is cut those tabs, do a little finish sanding, and it's going to be good to go. And for the lid, let's now pop over to the lid here. Very simple. We're going to have our pocket toolpath on the edges and for the magnets. So let's do the pocket toolpath for the magnets first. Again, 0.26 inches deep with an 1/8 inch end mill. So we'll go ahead and calculate that. All right, excellent. Then we'll select our two rectangles here. This pocket toolpath is, we're going to go 3/16 of an inch, 0.1875. If you remember, that's how much out of our 3/8 our lid's going to be recessed 3/16 into that channel, and that's going to leave 3/16 of an inch of material there, so we need to mill that out. And we're going to use a 1/4 inch end mill for this. I could, if I didn't want to do a tool change, I could stick with the 1/8 inch end mill, but I don't mind doing the tool change and everything. And so we're gonna run that pocket, and then of course a final layout or final profile cut. Now once I show you the basics of just a very basic box, and this is it, once we do the profile cut here, we're now gonna take this lid job and make it a two-sided job, and we're gonna do some laser engraving or inlay work on it. So we're going to step it up a notch. So this is the basics here. So this lid is going to be cutting all the way through 3/8 of an inch with our 1/4 inch end mill. Again, we can add some tabs. Let's go here, 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 and here. And we'll calculate that. All right, let's preview all the toolpaths there. Okay, so we'll end up with this lid here, our nice little overlap that's going to go right to, you know, our channel area that's going to slide in that channel, and then our magnet areas and stuff. Again, we'll have to trim the tabs. I'm trying to get my words there. Trim those tabs and do some nice cleanup sanding. And on the back side, I would break that edge, whether it was a little 1/8 inch round over or just some sanding, and just kind of break that sharp edge so it has a nice rounded over edge to it. But that is a basic layout for our base and our lid. Okay, now let's step it up a notch by giving our lid a little bit of decoration. All right, you guys good with this? You guys, like Jerry Brown is saying, we could do a sliding dovetail and things like that if you wanted to. You could do all kinds of things, you know, with that. This is just a straight sliding piece. It's not a sliding dovetail where we have an angle on our lids or anything like that. It's a very basic sliding lid box. Yeah, all kinds of things like that. You could do those variations. So thanks, Jerry. Hey, Jerry Brown. Hey, buddy, how you doing? Polly wants a crafter. How's it going, bud? I hope things are going well with you. Now, let's enhance this project a bit by doing some inlay work. So the first thing I'm going to do, I'm going to keep my same vector layout here, but I'm going to go back to the job setup on this lid, and we're going to change it to a two-sided job. Okay, and on this here, what I am going to do is on my width, because I do want some alignment pins in here. If I'm going to do this as a two-sided job, I want to put some alignment pins in here. So what I'm going to do is on my height, I'm going to just give myself an extra 1/2 inch on each side, and I'm going to make this a 6x5 piece. Okay, and where I could have went 4 3/4 or whatever, but 6x5 is fine. By 3/8, I will be referencing off the material surface on both sides, working off the bottom left corner, and I'm going to flip it along my y-axis here. And let's take that, and let's go ahead and get this centered on our material. There we go. And now I've got some extra room on my width here for some alignment pinholes and all of that happy jazz. Let's go ahead and get those put in right now. I use 1/4 inch wooden dowels, or you could use, I also have a set of 1/4 inch metal pins that are 1/2 inch long. Those work great as well too for your alignment pins, and they won't kind of expand and contract on you sometimes. But my 1/4 inch diameter holes, I'm just going to throw one over here, and I'm going to throw one down here. It doesn't have to be any specific place, just where I want them to be, right? Because I'm going to mill these holes into my material, and then there's going to be a 1/4 inch deep hole, the mirror version of this, in my wasteboard, so that I can stick those pins in and flip this over. My pins are 1/2 inch in length, whether they're the wooden pins or my metal pins. So therefore, I mill a 3/8 inch deep alignment hole into the wood and a 1/4 inch deep hole into my wasteboard. All right. So with that, I want to go ahead, and there's a couple of things that I want to bring over to the other side. So I definitely want my alignment holes, my perimeter here, and my magnet squares. I'll tell you about why I have those in a moment. I want those three vectors. I want to right click and copy them to the other side. And I've already got the tool paths created for this side. The only tool path, if this is a two-sided job now, the only tool path I'm missing are my alignment pinholes. So let's go ahead and get those put in. It's going to be a drilling operation. I'm going to go 3/8 of an inch deep. I can't go 3/8 on this one because that's how thick my material is. No, I can. I can go 3/8. What am I thinking? It's going to be a 1/4 inch end mill. I don't know what the hell I'm thinking. I can go 3/8 deep. That's not going to be a problem. 1/4 inch end mill. I'm going to use pecking on that, and I'm going to retract above the cutting start depth there. So let's go ahead and just call this my board alignment holes. 0.25 end mill. All right, and we'll go ahead and calculate those. All right, so we'll get those alignment holes put in there. And all right, so now let's flip over to the other side. So I got a little icon here that'll flip me over to side 2. And on side 2, I have my alignment holes. I've got my perimeter vector, and I have my magnets areas here. And the reason why I did my magnet areas here is because they're gonna, for me, they're gonna be my reference area of where my boundary is, where my magnets are. If I'm gonna do any inlay work, if I'm gonna do any V-carve work, if I'm gonna do any laser work, I want it within this perimeter between these two magnet holes. I do not want to extend out to the edges and everything. I want to, you know, I want to make sure that I don't go over those magnet holes because I don't want to cut into them on, you know, from, you know, this side, this top side and all. So that's the only purpose, the only reason that they're here on side 2, or the top side of this, is for this purpose. Just kind of give me a visual of where my working area is on that, right? So let's get rid of that rectangle. Okay, let's go ahead and while we're here, let's just kind of create our tool path, our drilling tool path for our alignment holes. This is going to be a 1/4 inch deep into the waste board, and this is going to be our waste board alignment holes. 0.25 end mill. I don't like spaces in my file name, so let me, I don't know why I kept hitting the space bar after doing that, but okay, let's go ahead and calculate that. And that, those will be cut in the waste board, so we won't see them from the top side and everything. Okay, now for my vectors, I've got some vectors kind of pre-made and everything. Let's go ahead and grab these and let's copy them and go back to our lid design, and I'll paste them in here just to give some ideas. And let's kind of look at it here. I got a nice little 2 kind of variations on like an infinity heart. Those would be either great inlay or V-carve. I got a nice sea turtle, not V-carve, but laser engraving. I got a nice sea turtle. That would be cool for, you know, someone that likes outdoors or what have you. And for the guys, you know, I got a nice deer here, you know, a nice buck and all. But again, it could be a nice decorative design. It could be someone's name. It could be whatever you want it to be, right? But these are the 4 examples that I'm going to be using for this, and we're going to go from there. All right, let's go ahead and pull all of these over a little bit closer. Pull these over a little closer. And all right, bear with me a second. There is an interruption that I need to get turned off. I'm in the middle of teaching a live class. I will get with you as soon as class is over. Thank you. All right. Had a customer text asking me a question about a carving, and I'll get with him later. Okay. So we're going to go ahead and let's start off with our sea turtle. That'd be a cool one. So let's go ahead and size this a little bit more appropriate. And I want to make sure that I'm centered. My project is centered on my material, so all I have to do with the sea turtle is just align it to the center of the material, right? And you know, I'd be laid out there. Now this, I've actually laser engraved this little guy, the sea turtle, and it makes a wonderful, very cool laser engraving. It would also be a very nice inlay as well, for sure. Let me see here. Bear with me a second, folks. Laser. Bear with me a momento. And let's see if how quickly I can. All right, let that search for that image. I'll show you this if I can find that laser image. But let's go ahead and create this as a, we're going to use the Vectric laser module. Here we'll do it as a laser job first, and then we'll do it as a V-carve inlay. Okay, so first one will be a laser, then the second one we'll do as a V-carve inlay. So for this, I'm going to be using a 6-watt laser engraver. I'm going to go with a I don't need it that deep. I'm going to go with 50% power on this with a move rate of 48 inches a minute, 1200 millimeters per minute, and single pass. It's going to be a hatch fill, so I want to laser engrave fill that. And I like going at a 45-degree angle. I definitely don't want to cross hatch this. It's too small to cross hatch, and that, you know, could become a serious issue, fire hazard or what have you, whatever the case may be. So I don't want to cross hatch that. And let's calculate that out. Let's select the vector first, Laney, and calculate that. All right, so in most cases, my lid is going to be, I like the base being the darker wood. I like the lid being the lighter wood, but again, you can mix and match. You can do all kinds of things. So I'm going to simulate this in maple here for the lid. And let's preview that laser engraving and everything. So cool little sea turtle there. Nothing wrong with that at all. So that would be that option. Let's go ahead and create a profile cut. Now, as a two-sided job, I'm going to most likely cut halfway through on one side of my material, halfway through on another, or I'm just going to cut all the way through on my second side, whichever side I'm going to do last. And a lot of times I kind of do half and half. So for the profile cut, I'm going to cut halfway through this material, which is 3/16 of an inch deep. And at this point, I've got to be mindful of my tabs. Tabs start from the bottom of the cut when you're cutting straight through. And on the bottom of my box, Once I get about 3/16 of an inch down, there's nothing down there. There's nothing at the bottom of that cut for a tab. So on this type project, I probably, to eliminate the use or the need of tabs, I would probably use a two-sided tape or tape and painter's, CA glue, painter's tape and CA glue, or something like that. Because if I can go ahead and add the tabs, but they're only going to be 1/16 of an inch thick, 0.0625, and the tabs are there, great. So I can go ahead and calculate that. And let's go back to the other side for a minute on the profile cut. And let's change that also to 0.1875 and recalculate that one as well. And that way, when we preview all of the tool paths for, both sides and everything, you'll be able to see kind of what my dilemma is. Let's preview all sides on this. Okay. And when we flip this over here, hold on. What in the world? That's my lid. Hold on, something got misaligned. What got misaligned? Oh, I got to recalculate these three toolpaths. They were created on that single-sided job, ladies and gentlemen. So let's recalculate all those toolpaths. Wonderful. All right, let's try that preview again. I was like, wait a minute now. Preview all sides. I was like, wait a minute. That's not going to work. All right, let's go while this is previewing. Let's answer some questions and all. And let's see what we got here. Why not finish the edge with a dovetail bit so the lid slides underneath? Jonathan, you could do a sliding dovetail. Like I said, this is a straight sliding lid box. And if you're going to use a dovetail, if you're going to use a dovetail bit in your CNC, you would set that up as a dummy tool path using a dummy bit like an end mill, because we can't draw a dovetail bit in the Vectric software. And when cutting the cuts for the base, where we have that dovetail cut, that undercut and everything for our base, now our lid has to have that chamfer, that matching degree angle. We can't cut that on the CNC because the dovetail bit is facing down. If it was facing up in a router table, no problem, all that good, happy jazz and all, but we can't come down. So we're going to have to use a V-bit that matches the angle to create our chamfer and everything. We'd have to use a V-bit that matches the angle of our dovetail bit, or we're going to have to use, set up a chamfer toolpath in a way that when that lid gets cut with that underside angle, this side angle here, that's going to slide into that dovetail, that locking groove and stuff, then you've got to make sure you've got the bits that match, right, for that dovetail, because we're coming downward, not upward like a router table. But yes, you could do a sliding dovetail box. Very, very simplistic. This is just a sliding dovetail, or this is just a sliding lid box. It's not a sliding dovetail, but that is one of the variations, okay? You just have to make sure whatever dovetail bit you're using on the base to cut that undercut where that base comes up. We've got that undercut where the lid's going to slide into it and everything. Your chamfer on your lid has to match that dovetail, and your dovetail bit doesn't cut like that, right? So we can't cut the lid with the dovetail bit. We're going to have to do it with a chamfer bit or a V-bit or something. So Jonathan, hopefully that answered your question. But yes, it is doable. let's see here. Or you could just take that dovetail bit out, take it over to your router table, and cut the lid edges on that way. Let's see here. I'm doing very good, Jerry. Getting back, I'm about to get back to my other channel. We've been announcing it the last couple of weeks. But I'm doing very well. Thanks for asking. Let's see here. Suicide all times. You said laser. I have a question. Is there a way to use a 3D path with the laser other than getting the add-on post-processor? No. The laser module allows you to do 3D shading on a 3D model, as well as you could almost kind of do 3D engraving with a laser and all, depending on how how the toolpath lays out and stuff with the laser module. But doing it as a straight and everything, no, you're suicide at all times. It's not going to happen. You're going to need the add-on laser module. You're going to need the add-on laser module for lasering 3D, especially with shading and highlighting your 3D models and stuff like that, because it's not going to be able to do it with a straight pocket, quick engrave, or profile. It's not going to happen. We need that pulse width modulation. So it shuts on and off, on and off, on and off, on and off. Or it changes intensity, you know, 60 degrees to 0 degrees, 60 degrees to 30 degrees, you know, or percent, not degrees, percent. So we need that modulation and everything, so we get those lighter and darker areas, those deeper and shallower areas and things like that. And the laser module add-on provides that, where the regular toolpaths do not. Okay, let's see here. Blue Knight, would you get a nicer hole with an 1/8 inch end mill instead of a 1/4? Yes. So Blue Knight's referring to our waist alignment holes. We have an option of doing a drilling toolpath versus if you use an undersized bit on that hole, you can do a pocket toolpath. Now, cutting the holes with an undersized bit and a pocket toolpath is going to give you a much cleaner hole and much more tighter parameters and everything on that, because when you're drilling, depending on your CNC and its rigidity and stuff like that, there's a possibility as you come down that bit slightly flexes when it makes contact with your surface. It slightly flexes, and then when it catches up, then it straightens out and drills that hole. But at that point, the top surface has been wallered out. I think that's a word, wallered. It's been wallered out and everything. That's a possibility if your CNC is not very rigid. Then there's a possibility of wallowing out that hole, especially on that first plunge, you know, and things, and even on the second plunge and stuff. But using an undersized bit and pocket cutting that'll give you a nice precise hole. So that is an option. I did not do it here, Blue Knight, because my digital wood carver is pretty rigid for myself, and I've never had any issues with my drilling and my holes being, you know, right on the money. But if that would have been an issue, or if I was concerned about any kind of flex or deflection of the bit, then I would use an undersized bit with a pocket cut, just like you mentioned there. And yes, you know, you'd get a nicer hole, right? Great question. I use the CNC to make sliding dovetails for my zero clearance throat plate for my table saw. Excellent, Jonathan. Show me how you did that. Make a video for me or something and let me know how you did that and everything, and then I can post it up and show everybody, because I'd love to see you know, how you did the male versus the female cuts and all. It'd be pretty cool. Absolutely. For your zero clearance plate, and the female cuts and the male, and then we'll address that, and we'll create another class and we'll do that. If you could make some kind of on your cell phone, everybody's got a cell phone that can shoot a video, kind of walk me through it, and you could email it to sales@digitalwoodcarver.com. I'd love to see it, and that way I can kind of see what you're doing and how you're doing it, what your approach is, because it'd be beneficial to me, educational to me. I love anything that teaches me something, for sure. All right, so here's our lid, right? Our basic lid here, and we've got a nice little laser engraving on it, right? Pretty cool. Let's look at my tabs, and we can see here that part of my tabs got cut away with that side one. So really there's only just that about a 1/16 of an inch of the tab from side two holding it, which is fine. That's structurally sound enough. It's not too thin there, so I'd be happy with that. I'd be content with that. But part of my tabs got cut away, and I knew they were going to get cut away, but I just didn't know how much they were going to get cut away. But there is still plenty of tab there for holding that lid, so I would be good with that and everything. And yeah, that looks good. If I wanted to be more secure, then I would, from the bottom side, I would do a profile cut. That would be the final side that I cut. I'd do all my laser engraving or inlay work first, and then I'd come to the bottom side and I'd do a profile cut all the way through, so that my tab has, let me see if I can get to that angle. So my tab has this lower meat here to, you know, because the tab starts at the bottom of the cut on that profile cut. At the bottom of the material, the tab starts from the bottom up, right? So I have all this meat here. So if I just did a single pass all the way through on side two, my bottom side, then I could put my tabs down there. But by cutting half and half, you know, part of my tabs are getting cut away. And I'm okay with that because there's still plenty of tab there to secure that. But yeah. And for sure, man, we could, I'd love to see that for the sliding dovetail lids, because those are nice working boxes as well too, for sure. Absolutely love it. I'd love it. I'd love it if you could do that, man. That would be cool. I would I'd love it. All right, so let's go and look at another design here. Let's see, let's take, I don't know why I can't select things tonight. Let's grab this deer. Let's say we're going to make a box for the guys or the girls or whatever the case may be. Now on this one, I would rotate it 90 degrees. Let's get it aligned to the center. Oh yeah. And this one would also make a decent laser. As far as an inlay, if I had some contrasting materials, I could do a pretty decent inlay with that. But let's take a look at it as a laser engraving, and then we'll do some V-carve inlay work. We'll do some V-carve inlay work. So let's preview all sides. And is it possible to do more in-depth laser session? Is it possible to do a more in-depth laser session? I've got videos where I do a more in-depth laser session on laser engraving on tile and everything, where it talks about the laser in depth and creating a vector, basically, if you will, or a photo, getting a photo ready using GIMP, importing that into Vectric, and then creating your laser tool pass. So there's a video on the Spindle TV channel that talks about that. And I'm actually going to refer you to a couple of guys as well. A couple of videos that I like, and one of my videos was based off was 3D Print Farm. I believe that guy's name is oh shit, I know his name. I want to say it's Jeff or Jerry, but 3D Print Farm. Check out his channel, and definitely check out The Edge of Tech. He shows some cool in-depth videos, you know, on working on canvas, scratch pad, tiles, and things like that. So he does some good stuff. Now they're working in light burn for the most part because they're using like a little Endura laser and everything. But basically what they're doing in light burn, we would be doing in Vectric, right? And in my video, how to laser engrave tile, I show that how to create those toolpaths in Vectric. But yeah, we can do more laser videos in the future. Absolutely. There's no problem with that at all. For sure. Yep. And once I start doing the full length videos where I'm doing the actual full build of the projects and everything, then we're going to be getting into more in-depth type of design topics and stuff, such as laser and fourth axis and rotary and things like that. So I'm looking forward to those as well. But yes, we can. Cadley. Sure can. For sure. All right. So let's take a look at this. Oh, yeah. That'd be a pretty cool lid on a box. That'd be a nice little design. And everything for a laser engraving. Now, think of this as an inlay, right? If we were to inlay this, our darker material where the... I would want this as basically 2 species of wood. I would want a darker material. If my lid was maple like this, then I would definitely bring the walnut from the base. I'd bring the walnut back in for this portion of the inlay. And it's basically doing an inlay of the entire deer, getting all that walnut filled out, and then just inlaying these parts here with maple again. Or it could be, if you want to go a little darker, you could go cherry or something, but we want that contrasting color. So it's a multi-step V-carve inlay. We'll look at that in just a second on creating that as a multi-step V-carve inlay in just a moment. All right, so, but that would be a very cool laser engraving. All right, now let's focus on inlay. Before we get into multi-layered inlays, let's just talk about a basic V-carve inlay using a simple contrasting piece of material. Ammo box, there you go. Or a box of deer jerky, there you go. Yeah, exactly. And, you know, however you want to do. Now, an ammo box... the magnets, they'll be strong enough to hold the lid on, but you might want a little bit better security on that so someone don't run away with your ammo, especially with these shortages nowadays. All right, let's see here. We're going to do, let's do this decorative heart inlay here. Let's get that on the board. Now, my V-carve inlays, regardless of if I was doing something on a small project or a larger project, they're pretty much rinse and repeat for me. It's the same. I use the same settings every single time. Very rarely do I go off the settings that I'm gonna be showing you here. And even in my past inlay videos, it's gonna be the same settings and everything. But there probably would come an occasion, especially if you're doing like a butcher block. Or something like that where you need a deeper inlay, you need some, deeper cuts and stuff and all that, then you may want to use a deeper settings than what I'm about to right now. The only thing that I need to stress is, I wish I had a V-bit here, is you need to make sure that your cut depth on your, especially on your female pocket and your male parts, do not exceed the cutting length of your V-bit, your cutters. Because if they do, when it's coming down and cutting, your straight edge and everything is going to create this straight lip at the top of the cut that's not going to fit. It's going to keep it from fitting and everything. So you have to make sure that your V-carve bit that you're using, whether it's a 90, 60, 30, 22, I don't care what it is, you need to make sure that the cut depth doesn't exceed the cutter length. The cutter length on the V-carve part, not the part that goes straight up. Most V-bits, especially like a 90-degree half-inch V-bit, they come up and straight up. Let's look at our tool database here. We can see a graphic Dum-dum-dum. Okay. In this graphic here, you can see we have our V angled bit here, and then it has a straight cutter on the two edges and everything. We don't want to exceed our cut depth. We don't want it to exceed that cut length there because we don't want to get into that straight lip. If we get into that straight lip, then our inlays, especially on a V-carve inlay, we're going to have some issues. And we're doing a V-carve inlay versus a traditional inlay because the detail that we're working with is very small, and we have some sharp points here and there and things like that. So a V-carve inlay is going to be the best for that. What am I trying to say here? The V-carve inlay is going to be the best, but I'm working with a small piece, shallow cuts. So here we go. Let's get this sized up. Matter of fact, looking at that, that's actually not a bad size as it is right now. Let's go a little bit bigger. And let's make sure we're centered. We are. Wonderful. All right. So with this, we're going to start off with our female pocket. The female pocket is, for me, going to have a flat depth of 0.2. So a 0 start depth, 0.2 flat depth. Now, this flat depth is what I'm talking about the cutter depth. I'm going to be using a 60-degree 1/4 inch V-bit. My cutter length is 0.21 inches on that V-bit. My flat depth cannot exceed that 0.21 inches, or I'm going to get this kind of straight meat, and where basically my bit is colliding with the material, and it could cause it to break off and chip, but it could also cause it to create this kind of straight cut. It's not really going to be a cut. It's more going to be kind of ripping through the wood, but where it won't fit into my inlay, right? Especially when I'm cutting the male part and all. So 0.2 is my maximum cut for the particular bit that I'm using. I use a 60-degree 0.25 V-bit. You can do a 90-degree V-bit, you can do a 30, you can do whatever size V-bit you want. Just I stress that make sure that the flat depth, your pocket depth basically, does not exceed the cutter length. Okay. All right. And let's see here. That's funny, Jerry. All right. So for this, it's just going to be a straight 60-degree V-bit, 0.2 flat depth. This is going to be my female inlay. Cut. We learn how to spell, Lord of mercy. Inlay cut. Okay. Boom. And let's reset that preview and preview that visible toolpath. Okay. Bear with me. I had the wrong bit in here. I had a 22 instead of my 60. Let me grab the 60 and let me recalculate. I could tell immediately because my 60 wouldn't go into the flat too much. So let's reset that and preview that cut again. There we go. All right, excellent. So this is going to be my female inlay here, my female, the receiving end of the inlay. And this, I'm going to bring in most likely the base material, whatever the base of my box is, if it's cherry, if it's walnut, if it's babinga, if it, whatever. I'm going to most likely bring that up into the inlay as well, so it kind of ties everything together. Or it could be a totally different species, whatever looks good, right? And for me, I'm kind of wanting to tie things together. I want to tie the lid to the box. The lid's going to be a completely contrasting color, so the inlay, I definitely want to, bring some of that walnut back in if that's what my base is, or that cherry or what have you. But we could absolutely do different colors, right? All right, so now when it comes to creating the male, I don't need to cut the male out of a 3/8 inch piece of material. I could, that means there's going to be some waste, right? And it's scrap wood anyway, or what have you. and stuff, unless I do like a gang of these boxes, you know, out of a long board, and I'm just cutting a, you know, a whole gang of them up, you know, for production run or something. But if I'm kind of throwing, you know, my one-off scraps and stuff in here and all, I don't mind if there's some waste that's going to get milled away when that mail gets milled off of that, you know, the waste area gets off. But I would probably carve the mail out of, you know, maybe a 1/4 inch thick material so that I don't have a whole lot of waste, or 3/8. So if I was going to do it out of a thinner piece of material and everything and set this job up, do I have to, once again, do I have to create a whole nother project file to just create that toolpath? And the answer again is no, we don't. And I'm not going to this time. I'm simply going to create another layer. So I'm going to add a layer here, and I'm going to call this first layer my female. Man, I cannot spell tonight. Female inlay vector. Inlay vector. And then I'm going to create another layer and call it my mel. Inlay vector. I don't know why I like that capital N. Okay, so on this heart here, let's go ahead and move that over to my female inlay vector layer. So it's there. And now I want to copy that to the mel layer. Let's go ahead and turn off the female layer here, and I'm going to also turn off everything else. And on this, I need to create some type of boundary. Now I could create just a rectangular boundary, I could create a circular boundary, I don't care what kind of boundary it is. We just need to clear out that material from around this mel cut. So everything's going to get cut around this mel cut. So I'm just going to go ahead and simply extend this out past my board here. And we'll center this on the material. And that'll be fine. And for this one, we are going to select this boundary and this, and it needs to be mirrored. Now I don't necessarily need to mirror the rectangle, right? But I do need to absolutely mirror my design. For the mel, it needs to be mirrored. So we like two slices of bread, you know, coming together for that sandwich. We're going to have our mel inlay that's going to flip and fit into our female inlay. Okay, so I'm going to just mirror this really quickly. Let's go ahead and mirror this. Make sure I'm in my mel layer here. Mirror. I'm going to flip it horizontally. Whoops, undo that. Let's turn off create a mirror copy. We'll flip it about job center and mirror that horizontally. There we go. So now I have a mirrored copy here. Now I can create my mel toolpath. So this is going to be a V-carve inlay as well, but this one is going to have a start depth of, for me, it's going to be 0.18 and a flat depth of 0.02. Now, Becky over at Vetric does a really great job of explaining how a V-carve inlay works. And we could do a lot of different things. We need a start depth, whether it's a 0.1. If this was 0.1, then my flat depth would have to be 0.1. These two numbers have to equal the depth of my female cut. 0.1 and 0.1 equals 0.2, that kind of thing. Well, I don't want a very big glue gap. I want more meat in my inlay and less glue gap and everything. So my start depth is going to be deeper. So I'm going to start at 0.18, 0.17, whatever. But I want a deeper start depth and a shallow flat depth, 0.02. Let's get rid of that extra decimal there. And those two numbers, 0.18 plus 0.02 equals 0.2, right? They have to equal the cut depth of my female. For this, I have all this flat area here. I could use a clearance tool. For time, saving time, I could use a clearance tool, to an end mill, to clear all that out. Or I could just let my V-bit do all the work. If I don't want to do a tool change, it's just going to be a longer run. But again, this is a small piece, so it's not really going to be too terrible. But I will use a clearance tool for productivity's sake. And I'm going to use an 1/8 inch end mill. And we can go ahead and calculate that. It's just going to be a simple raster cut. I don't care about, or offset cut. I don't care about going with the grain or anything like that. And so when this cut occurs, preview the visible toolpath, we're going to get this female cut here. Now, what I'm going to do is I'm going to intentionally create a cut depth that is deeper, that exceeds my cutter depth, so you can see the straight meat that I'm talking about that would cause us problems. I'm going to come into this toolpath here, and I'm going to make this a 0.18, and let's go 0.03 and calculate that. Let's reset that preview, and let's preview that toolpath again. Now at this point, I'm exceeding my cut depth and everything, and all right, let me go with a little higher resolution. Let me turn my resolution up a little bit. Oh, what's not going to take forever? Let's go with a very high. Let's see if that'll do it. Let's preview that toolpath again. I need to get rid of that pixelation so I can show you what I'm referring to. Sorry for the wait. While that's going on, let's see if you guys are having a conversation with yourself or if you're asking me a question. I made a box like this, the grooves for CNC bits. Oh, okay, you guys are having a conversation amongst yourselves. Okay. All right. We're not going to see a whole lot of it here, but I'm going to give you a reference example to show you what it is. But right here, God, let me see if I can zoom in a little bit more. Right here, you can, where my mouse is pointing, you'll be able to see kind of a defining line. And this is where we're starting to come into the shank and everything, and the material is starting to straighten back up. Let me be a little bit more exaggerated. If you've ever read the PDF on doing a V-carve inlay, right? They use a flat depth of 0.3 for their female cut, and they use a 0.1 for the start depth and a 0.2 for the flat depth and things. Let me show you what this would look like if I was doing a 0.3 using my 60-degree V-bit because of the length of my cutter. Let's go here. And let's go 0.1. Don't matter what my start depth is, 0.1, and go 0.2 here for a total of 0.3. Now my cutter, my 60-degree cutter, only has a 0.21 cutter length. A 90-degree V-bit would have a longer cutting length, especially one that has a maybe a 3/4 inch diameter head and everything. But let's look at, so we can really see that straight meat that I'm referring to. Let's preview. Sorry, hold on. Stop. Let's reset the preview and preview the visible toolpath, because I really want to make it clear what could occur if you exceed your cutter's length, right? And I have definitely, in this case, exceeded my cutter's length by quite a bit. We could see it when I exceeded only by a few thousandths of an inch, starting to create that straight meet, but we'll be able to see it definitely in here. If I was trying to do a 0.3 cut depth, I would have to change my V-bit because my 60 degree 0.25 V-bit just won't cut it. All right. Okay, now we can see. Let me let it finish up and then let me zoom out. Okay. So you see this straight meet here at the top of the cut before the V carve starts. That is the shank of my bit, or the, you know, that vertical cutter on my 1/4 inch end mill. That's basically, that's showing, you know, I'm exceeding my cut depth, my cutter's, you know, depth and everything, and that's my shank kind of, you know, colliding with that edge and all. But it creates this straight edge, and that is not going to fit into my female inlay. I don't care if it was just that small one that I showed you a moment ago, or if it was this big old chunk of in meat. It's not going to fit in. It's not going to seat properly. So long story short, I'm going to shut up about it. I'm going to say it one more time. Make sure that your flat depth for your female pocket and your male cuts do not exceed your cutter's length on your V-bits, whatever V-bit you're using, okay? Okie dokie. Let's get back and get rid of that. Let's get rid of this one. Let's delete those. And let's go back in and fix this one. This should be a 0.02. Calculate. So that was an extreme kind of preview, that straight meet, but we don't want that, even if it's a small amount, because that's going to, that male's got to fit down into that female, that V cut female, and you know, there's not going to be any room for it, and it's not going to fit properly and all that stuff. So we definitely don't want that. All right, so now that I have the male cut and everything, the toolpath created for that, the only thing I would need to do is trim off the two edges. So we'll zoom out here as soon as it's done and show that. Excellent. All right, so let's zoom out here. Zoom out, zoom out, zoom out. Okay, so all I have to do now is trim off those two edges, run it through my bandsaw or whatever, trim it off, and now I can take that over and glue that into my female inlay. Now, let's do an inlay that's going to take multiple layers of an inlay. Like the deer, we're going to go back to the deer, and let's do an inlay that's going to take multiple layers so we get those contrasting colors and everything. And someone that really does this phenomenally on YouTube is either Brian Wood or MTM Wood, and I don't know if MTM Wood is Brian Wood, if he's just changed his YouTube name or what have you, but it's BRION Wood. But he makes these beautiful butcher blocks, V-carve inlay. He uses V-carve Pro, I believe. But he does multiple contrasting colors and all to create these beautiful inlay cutting boards and butcher blocks and everything. And I'm in awe. And now his butcher blocks and all sell for a pretty penny. But there are some fabulous examples in his videos, in MTM Wood, if that's not the same guy, but there's some fabulous examples of a multi-layered inlay. So let's go ahead and do that with the deer. Before we move on, any questions? I don't see any questions. I see you guys kind of talking about sliding dovetails again. That sliding dovetails is the topic of the night. I should have done a class on sliding dovetails. Let's go ahead and let's move this off. Let's go back to this deer piece and let's I don't know why I did that. I'm such an idiot. Hold on a minute. Let's turn off that layer there. We'll turn on our layer 2, which is our box lid vector, so we can get our deer placed in here. and we'll go ahead and get it centered. Perfect. Now, on here, I have some vectors. If we go back and look at the laser engraving, just really quickly, reset the preview and preview the visible toolpath here. All right, if we go back and look at the laser engraving, so I have my base, if you will, my base inlay is going to be the darker color. And then we're going to be following up with the lighter color. So the base inlay, we're going to be filling in this entire area with our, let's say, walnut. And then we're going to V-carve that cut again. And we're going to then fill that in with our contrasting color maple or what have you. Now, we could, in some instances, we could just do a just an inlay on just that dark area because it's kind of split half and half, but it's not going to be kind of the best way to do it. We're going to do this in stages, 2 separate stages. So looking at this, my ears and everything, we're going to be able to create that contrast. So let's go back into here, and so I'm using the toolpath to help me out here, so I can see what inlays are going to be the walnut. The laser engraving is going to be the walnut here, and then what vectors are going to be my other inlay. And since walnut is going to be the base color, then basically this whole thing is going to get you know, cut into V-carve inlaid into the female. So let's go ahead and let's create, we got to create the female again and the male this time. So let's go in and create our toolpaths. Let's turn this off for a minute. So we're going to have a, move this to a new layer. We're going to call this our deer female inlay. Would that technically be called a doe inlay if it's a female inlay? Deer female, a female deer. Okay, so our deer female inlay, we'll click OK on that, and then we're also going to copy that to another layer and call it our male inlay. And it's going to be our, we're going to have a male inlay 1 and a male inlay 2, and the same thing with the female. So let's copy that to deer female inlay 2 and male inlay 2. Deer. Okay. All right, so let's turn off every layer right now. For right now, let's turn off every layer except for our deer female 1. Let's turn this off. Turn this and this off, and we're going to focus on our deer female inlay 1. And the first inlay, none of the inside vectors are going to be there. So what we're going to have to do, we're going to do a little bit of cleanup over here, and we're going to separate this area here because that's going to be part of my second inlay. So I want to clean this up a little bit on this corner here. I want to kind of close this off and connect it. So let's do a little bit of node editing. And I should have done this prior to, if I would have thought ahead, I should have done that prior to everything else, all the copies that I made. But what I want to do is let's go ahead and delete this span right here and cut this vector here. And I'm going to join that with just a smooth curve. I'm going to actually pull this over a little bit and just snap it to there. Okay, to close that off. And let's make sure, let me make sure nothing else needs to be taken out. Okay, no, everything else is good. All right, so that's the only thing that I needed to clean up. So what I need to do now is with that cleaned up vector, because I need to be able to use that, I need to go in and, like an idiot, I need to go in and delete. Oops. I'm going to hit delete to get rid of that one. Delete for that one. And female deer inlay 2 is done. Male. All right, let's get rid of all those. Okay, wonderful. Let me put the word deer in there so I can keep things separated nicely. Okay, so on our female deer, we're going to copy this back over to those other layers. So copy to layer, copy to the female number 2. Wonderful. Turn that off for right now. Copy this over to deer number 1, male. Wonderful. Turn that off for right now. And copy this over to male number 2. All right, female number 1, deer inlay female number 1. We do not need any of the inside vectors. We only need the outside perimeter. So all the inside vectors are going to be removed. Okay, because we're going to be filling this all the way with a walnut. Okay. So we're going to come in here and on this one, we are going to do a V-carve inlay. It is going to, again, have a 0 start depth and a 0.2 flat depth if I'm going to be using my 60-degree 1/4 inch V-bit, which I am. So we're going to go 0.2 and we're going to go ahead and calculate this toolpath. This is going to be my walnut deer female. Calculate that. Okay. And that way all of that gets cleared out. Okay. And that will eventually get filled in with our walnut. You know, it's going to get filled in with the walnut from there. And then we're going to come back and do the detail work with the maple. All right, so with that done, okay, I probably, yeah, that's good. All right, so now on my male deer, let's go ahead and go back over here on my male deer inlay. Once again, I need to mirror this part. So again, so it's a mirrored copy. So on the male, that gets mirrored. So I'm going to flip that horizontally. And again, this is just going to be the fill. So none of the detail in the middle here gets needs to be there. So just the outside perimeter. And I need to create a boundary around this. Okay. And this is going to be a V-carve inlay. Again, going 0.18 inches deep for me and 0.02 for the flat depth. I want a very, this, when I'm doing multiple inlays, this is where it's really critical that I have a very shallow flat depth, because I don't want, when I start cutting my second part into this and everything, I don't want to all of a sudden, you know, just see a bunch of, you know, glue gap and all that stuff and just a big vacant hole and everything. And again, Becky on Vetric, if you watch our video on YouTube, the Vetric LTD channel, and you watch Becky talk about a V-carve inlay where she's doing kind of this multicolored flower, she does a really nice job with a PowerPoint presentation explaining the process of this and why this is critical and stuff, and all. So definitely watch that if you ever get a chance. With this, again, I'm going to be using my 60-degree V-bit and my 1/8 inch end mill to do the flat work, and we're going to calculate this. This would be out of a contrasting, you know, out of my walnut piece of material that I would be cutting the deer out. Right, once the deer's all said and done. Y'all still with me? Just checking because the conversation stopped in the in the chat. I just want to make sure y'all are still there. All right, so this is just going to be the plug for that female, right? So it's going to be the walnut. It's going to fill that whole thing with walnut. Boom. And now I'll glue that in. You know, let it dry. All that wonderful stuff. Mill off the top. Get that nice and sanded flush, you know, and everything. And then I'm going to set it back up on my table. This is where alignment pins will be very helpful and stuff. Talking about the female piece and all. And then I've got to go back and cut the second female cut. So we're going to do that now. So we're going to turn off that inlay and go into our second female cut here. And on the second female cut, I'm going to be creating the areas that are pocketing out the areas where the maple's going to go. Right? Now, on here, basically, it's going to be all of these vectors here except for this, right? So it's going to be all these vectors that are going to get pocketed in, that are going to get filled with the male. So, we have to understand we have some small vectors here. Now, there is some trash in this that I don't want, that I don't need. So let's get rid of some of this trash. That there, I need the eyeballs. This here. All the square kind of trash vectors I don't need. Make sure it's nice and clean. Okay. So on this one, it's just going to be the inside vectors. So not the outside boundary, the inside vectors. And that's going to be a V-carve inlay. And once again, it's going to be cutting down to a, starting at 0, cutting down to a depth of 0.2. We're going to go with our 1/4 inch end mill. We don't need a flat bit for this. We're going to calculate that. All right, there's one open vector. I know which one it is, the one that I messed with earlier. Let's fix that. There we go. All right, let's do that one more time. All right, let's calculate that. Okay, let's turn around here. Preview that toolpath. Okay. And now for our male cut, turn this one off, turn on male number 2. Again, it gets mirrored, so let's go ahead and mirror and flip that. It gets a boundary around it. Oops. Make sure you're in the right layer when you do that stuff. Let's turn that off. Make sure you're in the right layer when you're drawing. There we go. I'm in deer inlay, male inlay 2, so let's create that boundary. And again, on this one, we don't need the outside boundary of this, so I can technically kind of get rid of it. Get rid of that trash that doesn't belong there, these little square vectors here. And this one right there. Okay. So on this, we're going to create the toolpath for this one. V-carve inlay, start depth of 0.18, flat depth of 0.02. And again, oops, where's my rectangle boundary? I think I accidentally deleted it. All right, select everything there and calculate that. Oh, still got that open vector. Hold on a second. Okay, one more time. Calculate that. And now this is going to be cut out of a thin piece of material as well, you know, or what have you. It's going to have a backer on it that gets milled away, so there's going to be some waste. But this is going to be that contrasting color. So we filled that whole pocket area with walnut, and now we're going to put the maple back in. We're going to put the maple area back in. So let's preview this visible toolpath. And that's what's going to give us that contrasting color. So we would come in and mill off the side edges there, run it through a bandsaw, handsaw, whatever. Take and glue this into that female cut, and then when it's all dried, give it a good, few hours overnight, whatever, to dry, really cure with a lot of good clamping pressure. Clamping pressure is important, and then mill that off. And now, basically, what we should have is if we were to look at this again. This time I'll do it with a global fill color here. It's not going to give me a global fill color on a laser. Nope, it's not going to give me a fill color on a laser. Okay, I can't use a fill color on a laser. But anyway, we don't need that. We can just look at it here. So pretend that that's brown like maple, right? So basically, when we fill in that whole area with maple and we come back and inlay, or I'm sorry, with walnut, we fill in that whole area with walnut and we come back and inlay the maple areas in, that'll give us that contrasting color. So it's going to be a multi-level, a multi-layered, if you will, with contrasting materials and all, inlay and all. And it looks very attractive. And you know, if I wanted to, I could use that walnut for that dark brown. I could use maple, or I could use cherry, depending on what kind of contrasting color. But I'm more apt to using the maple, right, to bring that color back in and stuff. But again, whatever looks best, whatever looks best and all. Now, someone has a quick question: what glue do you use, and how much time? So I use Titebond 2. I'm a Titebond 2 guy for my indoor projects and things like this. Titebond 3, if there's going to be any kind of contact with water and stuff, or maybe an outdoor project and everything, I use Titebond 3. But this would be a Titebond 2, and I would personally, I would give this either, I would let the inlays sit under clamping pressure overnight to fully cure. It's going to somewhat cure after a few hours, but because I'm going to be remilling this and I don't want any loose areas to come out or anything like that because the glue hasn't fully set, I would honestly let it sit overnight and give it time to fully cure, a good 24 hours or what have you, to fully cure before I did the second inlay cut on it. and because we don't want, while we're milling those pocket areas and all for that second part, we don't want that bit to pull some of those areas out because they haven't been fully glued or secured in properly and things like that. So Big Daddy Fish, Tight Bond 2 for me. This is an indoor project, it's a little gift box, and I would let it glue overnight. So this project here, I would be doing all the box work, take just a few minutes, 11, 12 minutes or whatever to make the box. And then the inlay work, just another couple of minutes for that. Glue up the mail, that first mail in there. And then it would be set aside overnight while I was working on more boxes, right? I could multiple boxes and stuff, whatever they are, laser, this and that. I've got other things to work on and stuff. But while that glue is setting up, I'm working on other things. I could be going ahead and prepping and making my mail parts and all that stuff as well. And then, for the other, inlays that are coming up. And then the next day I would come in and finish it up, do the second part of that and all. And then once it cures and everything, then the box is ready for finish and whatever, gifting or selling or whatever the case may be. But it would be kind of the process, the glue dry time and stuff would be overnight. Let's see here. The little spike at the base of the neck is bugging me. Right, that little spike down here. Again, that's where you could go in and clean up the vectors. Let's go back into our female here. Okay. That little spike right there is bugging Jerry said, but that could be node edited, right? We could cut the vector here, zoom in and cut it here. We could delete that little part there and then just close up and join that vector with a nice little smooth curve to clean that up, right? To get rid of that and make sure we do it across the board on all of them and all that stuff. It doesn't have to be there, right? You can go through and clean up your vectors like this little hitch right here, and things, all those things could be cleaned up and addressed before we start creating the inlay. So that's a good point and all that stuff. I've been known to spend 6 hours hand drawing something due to being overly perfective. Absolutely, right? That was Jerry's quote. Let's see here. When you cut the deer female inlay 2, what if you use a cut depth of 0.18 to avoid any possible glue voids? Then cut the male for a 0.16 and a 0.12. You could do that. So what he's saying is if we're worried about glue voids in that cut, now remember we filled this whole thing up with walnut, so edge to edge and everything, and inside we're not going to have any glue voids or anything. But what Bob is saying is okay, to eliminate the possibility of voids, can we take the second inlay toolpath and cut that female at a 0.18 instead of 0.2, start depth of 0, cut depth of 0.18, right? That way we're not cutting all the way down to the bottom of the original female vector, right? Possibly exposing a glue void or what have you. Again, it's not gonna that's not gonna be critical unless we have a big glue void, right? We have a very small one. But he's saying, what if we cut the second female down to 0.18 and then on the male, start depth of 0.16, flat depth of 0.02 for a total of 0.18, and do the male that way, right? And so that way we avoid glue gaps and all together. Yes, Bob, you can absolutely do that for sure. No problem there. Just make sure that you got to remember the male, the shallower we go and stuff, the less meat, right? We don't have it's already, it's already a thin inlay as it is. So it's only a few thousandths of an inch that you're talking there, and that's not a big deal at all. Yeah, that you could absolutely do that. Not a problem. That would be on female 2 inlay 2 and male inlay 2 He's just wanting to cut it 20 thousandths of an inch shallower to avoid the, the glue pocket or something on the first one, which isn't a major glue pocket. But yeah, you could absolutely do that, Bob, for sure. Yep, yep. All right, ladies and gentlemen. So whether it be, V carving, whether it be laser engraving, whether it be, and it doesn't have to be images. It could be text, it could be a little quote. It could be a Bible verse. It could be whatever, right? I love you. I don't know. Depends on what kind of box this is for, Happy Father's Day or World's Greatest Dad or, I don't know, Daddy Stash or whatever. But, whatever you want, we have a lot of different options. We can just do a simple V-carve. We could do a resin fill on it, a V-carve with a resin fill, with maybe some little colored resin. We could do a laser engraving on it. We could do a inlay and things, or we could just do a plain box lid, right? Just a plain bare box lid. And now we've got all these small little scraps, 6x4 blocks of wood, 1.25 inch thick to anywhere from 3/4 of an inch thick to 1.5 inch, depending on how much capacity you want that box to have. But these little scrap pieces now, we can turn them into profitable little boxes that we could sell, or gifts that we could give away. They're great for, for little things like when you're buying your 16-year-old new car for their birthday or something, and you need a little box to put the keys in, and something, make a little decorative box for them, that really means something to them. They could be, Pokemon fans or Fortnite fans, and we're doing some kind of little design or something, and I don't know, right? Anything. Use your creative. It could be military logos. It could be whatever you want it to be, right? And but we could create some really nice looking boxes with our magnets lid. That lid could close on, or it could slide open and closed. And when we slide it open, there's a magnet on the second side, so the lid catches with that second magnet, so it doesn't fall off, right? So it's pretty cool. We got a magnet on each end, and all kinds of fun stuff, right? And have you done any laser training classes? Yes, I have videos on Spindle TV for laser engraving. Kool-Aid, definitely check those out. Have you ever done a person photo with a laser? Like an actual person photo? Yes. In that, when you're, doing a person photo with a laser, let's turn off this and add a new layer here. Let's import a photograph, and let's see here. We'll use this cute guy right here, we'll that'll be our photo. Of course, we could take this into a photo editing software and do some trimming on the background and clear that out and all that stuff, whatever the case may be. But if I just wanted to carve, laser engrave just myself, then I would absolutely take this into a photo editing software, GIMP, Photoshop, whatever, and clear out that background. Otherwise, I'm going to be laser engraving that background, right? And what have you. I do have some editing, image editing functions over in the drawing tab of Vectric over here. I have a picture editor that can help me do some contrast, brightness, and gamma adjustments if I need to. If I need to kind of bring out some of the contrast and edges and everything. Oops, wrong way. Let's bring the gamma down a bit. Bring some of the edges out and stuff, define some of the parts and all. This is me in my old shop. I could, grayscale it if I wanted to, whatever the case may be. And from there, I now have a photo that I can laser engrave, and I'm using the digital or the Vectric laser module, the V-Carve laser module for 10.5 or higher. The photo laser picture. 6-watt laser for this. I'm going to go with a maximum power of 50% on my 6-watt laser. Minimum power of 0. I want it to pulse width, that modulate between those two. I'm going to go for photos on tiles and wood. They're kind of similar. For me, my magic number is 48 inches a minute, which is 1200 millimeters per minute. If you guys are using light burn and stuff like that for a regular laser. 48 inches a minute. I'm going to do a raster. I prefer a raster over a dither anytime versus a hatch or anything. I prefer a raster. I want a dense raster. My light's just dimmed for some reason. Bear with me a second. There we go. I want a dense line spacing on this, and I want to go 45 degrees. I'm a 45 degree kind of guy, and we would calculate that laser engraving, and we can reset that preview and preview that visible tool path. Give it a second. I have one of those UFO WW plaques. Yes, Jerry. Yes, I need to get back to all of that, and I will when I get back into my other channel coming up. We're getting another shop, Jerry. I don't know if you've were in the last couple of classes, but getting a little bit larger shop getting underway, so we can start doing full-length videos on my original channel again, so I can get back to video making. And then there's going to be some aspect of CNC work in those projects that I'm going to be building, and so the CAD CAM design will be here on Spindle TV, and on our other channel, Build It TV, will be our main full-length video. So I'm going to get back in the shop and start making again, and need to get back into that. Jerry is one of the original UFO WW members, United Federation of Woodworkers. So we have a laser engraving of our photo here, and you know, we could clean that up a little bit lighter color, but I don't know if that'll affect it any. Nah. But anyway, so yeah, laser engraving of a person or a dog or whatever. Pretty straightforward. Import your picture. You can adjust your image. If you don't want any background stuff in there, like if I didn't want all that stuff, my shop in the background and those tools and all, then I would take that into a editing program before bringing it into Vectric. I'd take it into like Photoshop or GIMP or you know, Inkscape or something like that, and I think Inkscape's a photo editor as well. I would clear out that background. I'd get rid of that background and just have my subject there, and then I would import that image in and create that laser engraving, right? But in this case, you know, this would not be a fitting laser engraving for the top of a gift box. I would clean it up some, right? Now if somebody did, if they were giving me a gift box with a laser engraving of myself on it, you know, I'd prefer one with my dog on it or something like that. But yeah, so that would be pretty much it. Very simple and straightforward. And again, this is my 6-watt laser. I'm going about 50% power, and with a 0 minimum power, so I want it to modulate in those light and dark areas between those two powers and stuff. All right, let's see here. Off topic, your last video, you had a couple of 3D models for sale. 4th of July and another, what was it? So last week and all the way about 2 weeks back, I've been putting out these model packages for sale. You can email me at laney.shaughnessy@spindletv.com. I'll throw that in the chat, laney.shaughnessy@spindletv.com. I'll throw that in the chat area there. That's my email. And you can email me for a package, a model package that I have available for sale. I have, let's go into my File Explorer here. I got CC Cleaner over there. I don't know why that won't close on me. Let's go into my downloads. So what do I have here? I have my 4th of July model pack. The 4th of July model pack has some 3D models in it, such as this 1776 flag with you know, some V-carved vectors as well for the part of the Declaration of Independence, 4th of July. I've got let's move along. Simple V-carve America established 1776 sign in there. So there's another look at it. America, God shed his grace on thee. Those are just regular projects. I've got this Eagle Shield July, established July 4th, 1776. And then also the fireworks sign, God Bless America sign, and this state, God Bless America, Land That I Love, outline of the United States, and that also has an eagle as well. So that's the 4th of July pack. If you want that, it's $25 for all of those projects and those models. You just email laney.shaughnessy@spindletv with the subject line 4th of July project pack, and I'll send you an invoice for it. So that is the 4th of July pack. We have a 2A Second Amendment model pack that has a full project. This established 1776. I'm 1776% sure that no one will be taking my guns with the Second Amendment V-carved in the bottom AK model there. That model pack also comes with just the AK, just the flag, the 1776 flag, the flag with the AK model, and or just the stars with the 1776. That's a model in itself, and things like that. So that's the 2A pack. So the 2A dash AR-15 project, you can that's $25 for that, those models and vectors and everything. And then Father's Day is right around the corner, and we also have a Father's Day pack, which is eluding me for the moment. Stand by. There it is. Way down at the bottom. And this one has bear with me. I actually have to open that one. It won't show because I don't have any pictures. I didn't create any pictures of that one for some reason. I don't think I did. Let me go back and look again. Father's Day sample design. Nope. All right, let's open that up one real quick. Open that up. All these projects can be imported into Desktop Pro and Aspire. If you want the Father's Day pack that I'm about to show you, your email would have the subject line Father's Day project. So either Father's Day project or 2A AR-15 project or 4th of July project. And those are available. The Father's Day project is $15 for that. And it comes with a World's Greatest Pop-Up model. And it comes with 2 signs, a sign from a male or son and a sign from a female, a daughter. It's going to open here in just a second. I'll be able to show it to you. And yes, Peter, you can call me after class. You've got my number. So if we were to look at this one, and this one, preview those visible toolpaths. Let's let that here. Let's turn down the quality a little bit so it's not so take so long to preview. All right, so this one is, you know, a sign to dad from a guy, from the son, right? Let's reset that, and let's look at the one from the daughter. Great signs. They're scalable. You can scale them up or down, but this would be the one for dad from his daughter, and you can change and add the daughter's name or your name or whatever, stuff like that. These can be sold. You can, you know, carve them and sell the projects. Don't sell my designs, but sell the projects. That's fine. And then the last model for the Father's Day pack. Bear with me a second. I don't know why I don't have a picture of that. But the last project for the Father's Day pack would look something like this. Let's turn this off, and this off. And let's import. This one. Okay, so you get assign a 3D model. World's greatest Papa Bear with this bear model and everything, and that would be the third project. So those three projects, $15 for that. That's the Father's Day pack. Again, emails in the chat area if you guys and girls want to support me. That the money that's for those purchases, that money is getting used for the new building to help with the build and getting the new building up and everything, so we can get Spindle TV moving into the future for these full-length videos and stuff. So those purchases really help, because that money is going to go towards the purchase of the building and all. We're trying to raise $25,000. Well, I've got most of that. We're trying to raise some of the thousands of dollars for that, and the sales from the previous. We've raised a little over $2,000 in sales, so thank you all for whoever purchased those projects so far. Got a long way to go. I assume, you know, if I have I've got over 5,000 subscribers on Spindle TV, and if each one of those subscribers at least bought the Father's Day pack, then that would give me you know, enough money to get that building up and done and everything like that. But not everybody that watches my videos are going to buy from me and support. So if you do, great. Thank you. I appreciate that. All right, everybody. So let's really quickly, I want to end this video with a decent thumbnail. Let's see, what would be a decent thumbnail? Let's go back with the Deer Laser project. We'll just end with that, or it could have been the sea turtle, but let's go ahead and end with that cut, the profile cut, and preview those visible toolpaths. Okay, we'll leave that like that. And as I say my goodbye, that'll be the image that shows in the thumbnail. Wonderful. I don't have to do all that work. All right, everybody. Well, these little boxes, what I'm going to do is I'm going to make this file, both the base and the lid files available. Like I always do, I'm going to make them, not always do, but like I do for you. I'm going to put some vectors together, get the layers all organized, get the tool paths all cleaned up for you. And I will make those files and the SVGs and DXFs. If you don't have Vectric or you're using something else, I'll make the vector files available to you in SVG format and DXF. I know Blue Knight uses SVG and all that stuff. So those will be available, and that download will be available for free in the description of this video. Give me a couple hours to get it cleaned up and all that stuff, and I'll make those files available, and I'll put a comment, I'll post a comment in that video letting you know that the files are ready for download, and you'll have them. And these are some great little fun little boxes. I'll also, in the description of the video, will be the link to the magnets, whether you go with Amazing Magnets, which have them in stock. They're a little bit more expensive there, or Total Elements. They're out of stock. I don't know when they'll be in stock, but I'll put the links to both there for you as well. And I did put the links in the chat area earlier, but they'll be in the description again for you. So you'll have everything available for free download, and the links to get magnets and stuff, those 1/4 inch by 1/4 inch by 1/8 inch. If you get different magnets, make sure you adjust your vectors accordingly and tool paths accordingly and all that stuff. But I do recommend those because they're nice little small magnets. They're going to be a nice pressure fit, all that good stuff. But until next time, everybody, hopefully you enjoyed tonight's class. And yeah, be sure to email me if you want to purchase any one of those model packs. We'd love it. I'd love it. It would help me out tremendously. Until next time, see you soon. Like, subscribe, hit that notification bell, and we will see you next week. See you guys and gals and everybody else.